If we go back to fundamental theorem of calculus 1, this is f of t, dt, a is 0 up to x. Good. What does the theorem state? If that is the case, g prime of x would equal to what? Instead of uppercase f, I'm using lowercase g. So look at the theorem and tell me.
F prime of x with the one.
Yes, but what would it equal to g?
Like the actual number or like just theory?
F of t. F of t.
Is it f of t or f of x?
Or x.
X. So all you have to do is plug in x. The derivative of that is this.
That's it.
That's what you proved earlier. That was the whole.
Even if you plug in that lower limit, right? We're taking the derivative. What is the derivative of that constant? That'll go away. So this works out nicely as long as the lower limit is a constant. Upper limit is either x or a function of x. If that's a function of x, we've got to do this differently. I'll do a problem next time. Are we clear? So the lower limit has to be a constant for this to work. It is a constant, so h prime of x would simply be equal to ln of square root of x squared plus 1. That's it. You don't add plus c. We're not integrating. So there should not be a plus c. Easier way to remember is you're taking the derivative. What is the derivative of a constant?
0.
0. Most common mistake is when you go from here to here, people would add plus c. There should be no plus c. Enter.
With x over square root of x squared plus 1 be the same thing?
No.
Because I rewrote it before I did the ln, I did 1 over the square root of t2 plus 1.
That's not right.
No, that's not the same.
And then change.
Yeah, we can't do that. No. Yes.
How come we wouldn't be doing chain rule?
Because the limit is not a function of x. It's just x. Good.
So would you have to do some form of chain rule if the bottom, so what a would be if it wasn't a constant and it was a function, would you have to do chain rule at that point?
Now I'm going to show you how this would change if the upper limit was a function of x.
Could the lower limit ever be like e?
E is a number, yes.
Probably on text.
Could it be e raised to x? Absolutely.
I just think that's an important question.
The same problem, but I'm going to show you what would happen if I had that. So t2 x squared ln or square root of t squared plus 1. What is the difference between that and that? Instead of x, I have x squared. So h prime of x would simply be ln square root. In place of t, I'm going to plug in x squared. Yes, but am I done?
No.
No. Since the limit is actually x squared, derivative of x squared is 2x.
Oh, just.
Just that. You're taking the derivative of the limit because it's a function of x. So that would equal to ln square root x squared x raised 4 plus 1. If you know the properties of logarithms, we can rewrite it a different way.
Oh, it's addition.
Addition, what?
Enter.
So it'd be 2x over the square root. No, I'm wrong, right? Yeah, there's.
It's a good thing I have facial expressions. You just x raised 4 plus 1 raised 1/2. I'm just rewriting. So now what is the property of logarithms?
You take the one.
Could you apply the natural log for the field?
No, you.
No.
You take 1/2 out.
I'm taking 1/2 out, right? So 1/2 ln of x raised 4 plus 1 multiplied by 2x.
Okay.
The 2's will get cancelled. The answer is x ln of x raised 4 plus 1. On an exam, this is more likely to be an answer. You should know how to go from that to that. And do not put what in the answer? Plus C. No, it shouldn't be there. I'm going to show you, Lewis.
Why is it that we want the constant at the bottom?
Remember when I showed the arrow, we have upper limit minus some number.
Yeah.
Now, I will do an example where I could just keep it as is, or not example, the same problem. I'm going to keep it as is, and I'll show you how it can be done. So, first method, I want to use FTC1, which simply states, as long as I have pi over 4 in the lower limits, then I can plug in the upper limit, take the derivative, whatnot. Pi over 4 is not the lower limit, but if I use the property of integration, of flipping, I end up getting that. So minus sign, you plug in the upper limit, which is x cubed, but we are not done. Multiply by 3x squared. I get that, yes? No, that's knowing the fundamental theorem of calculus. If you didn't want to do all that, you can take this approach also. Okay. So if f of x is equal to x cubed pi over 4 sine u du, the derivative of that, derivative of the antiderivative, is simply the function that's inside the integral, correct? Yes?
Yes.
But the derivative is with respect to u, excuse me, with respect to x and not u. So when I take the derivative, there should be a d over dx for u. I'll do that later. So I'm going to plug in the upper limit, which would be sine pi over 4 minus sine x cubed since that is a function of x, I've got to multiply by 3x squared. Yes? I took the derivative of that part. What is the derivative of sine pi over 4? 0. You'll get the same answer, right? Of the two, which is easier? That one, right? Sure, I can go through this process, but I've got to be careful as to what I'm taking, what variable I'm taking the derivative with respect to, what should go away, and what should, that should change will go, all of those come into play. Yes?
We have to get 0.
Derivative of sine pi over 4. Sine pi over 4 is a constant. Derivative of a constant is 0. Yes?
And why do we take the derivative?
Because the derivative of the antiderivative, which is this, would equal the function, right? So I've put that function over here, from here to there. So I've got to take. What was your question again?
Why did we take the derivative of sine?
Derivative of the antiderivative will give us f prime of x, right? I can't simply take the derivative of this, I've got to take the derivative of both sides. The derivative of the constant would become 0. Derivative of just the x cubed, we're just taking the derivative of the limit, not the function itself. So minus sine x cubed, derivative of the inside of 3x squared.
But isn't what's in the integral already?
That's the whole point.
That is the point.
Okay.
Because the derivative of the antiderivative would be the constant.
What you're trying to find out is a specific point.
Come again?
But you're just trying to find it as a specific point.
I'm just trying to find it at x cubed using a
And
function.
what is the integral? Because I know like